Welcome to this video overview of a polynomial that we have to solve an inequality involving. In this case, the polynomial is on our screen, and when we're solving a polynomial inequality, or an equality for that matter, we need to get 0 on one side of the inequality in this case, and everything else on the other. So I brought everything over to the left-hand side so that the coefficient on the highest degree term is positive. Now, we also have a scenario where we are provided one irrational 0. Seems like a logical thing to have. And when we have an irrational 0 like this with integer coefficients on the polynomial, we know that the conjugate zeros theorem tells us the conjugate of that irrational 0 must likewise be a 0 of the polynomial. In order to proceed further, we are going to write out the corresponding factors involving those two zeros, where it's x minus one of the zeros and x minus the other 0. So this is what our factors are going to look like, and when we FOIL this expression out, we will have the x squared minus the quantity 4 plus radical 3 times x, that comes from this stuff right here. And then right over here, we're going to have minus the quantity 4 minus radical 3 times x. And lastly, a negative times a negative is a positive. The two conjugates multiplied together. So now as we combine like terms, we're going to have x squared. Notice that the minus radical 3x and the minus a negative radical 3x are going to cancel. So those things will cancel out there. And when we combine the other terms, we're going to have a minus 4x and a minus 4x yielding a minus 8x. Over here, this is basically the difference of squares, that handy technique. So this will turn out to be 16 minus 3, which is just plus 13. This quadratic trinomial divides our polynomial up above. So now we will proceed to the long division, which for ease of this video has already been completed. So perhaps you are working this problem independently of the video. If you were working independently and couldn't get your remainder to be 0 when you did the long division, perhaps hit pause on this video and see if you can identify where your mistake was. Once the division is completed though, we will continue in our process of factoring this polynomial completely. At this stage of the game, here's what we have. That x squared minus 8x plus 13, our divisor, times the quotient we achieved, the x to the fourth minus 4x cubed plus x squared plus 6x minus 4, is going to have to be less than 0. At this stage of the problem, what we do is we look at the polynomial that remains and we want to factor it, likely by identifying possible rational zeros and performing synthetic division accordingly. In this case, the possible rational zeros are plus or minus, don't forget that, 1, 2, or 4, because the factors of 4 are 1, 2, and 4, and the factors of 1 are just 1. We go through and do the synthetic division, noticing that x equals 1 is a 0 twice. So x minus 1, the quantity squared, will be a factor of the overall polynomial. Once we identify the factorization of our polynomial, don't forget to carry down the x squared minus 8x plus 13, and please don't forget to keep the inequality, where we say it's less than 0. We will identify the zeros of each of the factors. Over here it's 4 plus or minus radical 3, that's what we started with. The middle one, it's 1, what we found through synthetic division. And for the last one, we have to use the quadratic formula, and we get that x is equal to 1 plus or minus radical 5. Now, we put each of those zeros on a number line and analyze our inequality. So here's our number line pictured. Notice that we need this inequality to be strictly less than 0. So none of the zeros can work and be a solution. All of these will be open dots. Please label accordingly. Now we're going to pick a really large negative number for x as we go through and do this. If we pick a really large negative number for x, say x equals negative 100, and we plug it in here, this parabola, if you think about parabolas, on the far left it goes up. That's its end behavior. So for this one it's going to be a positive. A quantity squared is always going to be positive. And over here, same deal, that's also a parabola opening up. So on the far left it's going to be positive. Overall, 3 positives make a positive, and unfortunately that region does not work. We needed it to be less than 0. Next region, plug in a value of x between 1 minus square root of 5 and 1. Now you might say, uh-oh, that's going to be annoying to find a number that does that. Well, not technically, because square root of 5 is bigger than 2. 1 minus 2 is going to be a little bit less than 0. So 0 is going to work. If we plug in x equals 0, we get a positive here. We get a positive here. And over here, if we plug in x equals 0, we get negative 4, which would be a negative. On some level, I think the easier way to look at that approach is the following. Notice that when we went into that second region, we jumped over the 0 of 1 minus radical 5. This factor, the x squared minus 2x minus 4, is the one that has that 0. In fact, if we graphed it, it would be right here. That's where that parabola goes from being above the axis to below the axis, from being positive to negative. Hence, we know that that term is the one that's going to change to negative. Regardless, if that region is negative, it satisfies our inequality, and we shade it in. Next, we'll proceed to a number between 1 and 4 minus radical 3. However, here's what I think is the easiest way to consider it. What we're going to do is view and say, oh, if we're going across the 0 of 1, it's the factor that has that corresponding 0 that could change. But since that factor is being squared, it's always going to be positive. Hence, this region will remain a plus plus minus. Overall, it'll be negative, satisfying our inequality, and we will shade it accordingly. Next up, we are jumping over the region of 4 minus radical 3, which involves this expression over on the left. That's where this parabola is going to go from positive to negative. So really, without even thinking, we know that this could be negative, positive, and then this last one stays negative as well, making that region positive. Proceeding along, 1 plus square root of 5 came from the far right term, so now it's going to morph from negative to positive. The other two regions are going to stay the same. Overall, that's negative, satisfying our inequality, so we shade it in. And for the last one, when we plug in a value of x really large, like x equals 100, positive, positive, positive. All parabolas are positive there for the end behavior. That's going to be a positive. That does not work. Ultimately, for the interval notation of our final answer, so overall for our answer in interval notation, it's going to be round parentheses 1 minus radical 5, comma 1, don't overlook the fact that 1 is not a solution, union 1 to 4 minus radical 3, union 1 plus radical 5 to 4 plus radical 3. All of those round parentheses due to the strict inequality, and that would be our solution in its final form. So again, recapping this problem, first thing we do is get a 0 on one side, get everything else on the other side. Once we have that, we find and use the conjugate zeros theorem to identify a quadratic trinomial that can long divide out our expression, leaving us with a quartic polynomial that we do synthetic division on to obtain a quadratic polynomial, in which case we can't factor, so we use quadratic formula, put all of our zeros on the number line, analyze each region, determine which regions work, and finally identify the interval notation. If we follow that process, yes, the problem could be somewhat involved and sophisticated, but ultimately we'll have the structure we need to obtain our answer.